Hey guys, welcome back to my video series on solving LeetCode problems. I'm Alex, nice meeting you. So now we're solving problem 547, number of provinces. So what's this problem about? Let's say we have a bunch of, they have this story here that they call them cities. Cities are connected, they're indirectly connected, and provinces. So what is this? Let's look at this. We have this example here, 1 connects to 2, and node 3 is not connected to anything. So we say we have 2 provinces. Why? Because we have one set of connected nodes, and then another set of connected nodes. And here we have 3 provinces because we have one set of connected nodes, another set, and then another set. A node by itself is just one set of connected nodes or connected components. Another example here is we have 1 province because all of the nodes are directly or indirectly connected to each other. So I tried to solve it, and well, I went the wrong way, completely the wrong way. So I stopped the video that I was recording to record a new one. And I am going to delete this. So, actually, my solution passed 67 of all those cases, but it was not the right way to go. So, what is the way to go? The way to go is, let's look at this case here. And let's assume that, let's look at this. We have this case here. So we start with this place here. So we create a province called 0. Provinces equals 0 so far. And then we say that visited equals 0 so far. Then let's say, okay, from 0, which ones can I get to? And let's save on the stack the nodes we can get to from 0. So we can say, we can go to node 2 and 3. Okay, great. So before we move on to another node, let's just visit the ones that we have on the stack. So let's remove 2. We could remove 3, doesn't matter. Let's remove 2. And then, okay, we're at number 2, so visited 2. And we can go to 0. Well, but 0 is already visited, so we don't really want it. We don't want to visit the node again. And then we can go to 1. So also 1. And then we can go to 3. Cool. Nice. Now we need to add 1 to the stack. And we don't add 3 because 3 is already on the stack. Well, but we can add 3, doesn't matter. 3. Then, okay, let's visit 3. Okay, we remove 3 from the stack. And then it's like, oh, I can visit 0, but it's already visited. I can visit 2, but it's already visited. So, well, I'm done. And now we remove 1 from the stack. What can we visit from 1? 2. 2 is already visited. Never mind then. So now we remove 3 from the stack. And what can we visit from 3? Well, as we know, we already visited 0 and 2, so there's nothing we can do. Okay, so we have 1 province. So let's imagine we have another one here, which was node number 4. And this one's not connected to anything. So remember, we started with node 0, and then we just went through the neighbors and the neighbors of the neighbors. So yeah, okay, cool. Now we already saw node 0, let's move. Node 1, oh, it's already visited, never mind. 2, already visited, never mind. 3, already visited. Now we go to 4. It hasn't been visited, so it must be a province. What can it connect to? Nothing, so we put nothing on the stack. and there are no more nodes, so we end up with 2 provinces. Okay, I think this is the right way to go, so let me just implement this. So, let's see, for provinces equals, let's start with 0, provinces counter. We don't need to say which province it is, we just need a counter. And visited is a set, and also stack is a list of integers, that is this. So for index and nodes to visit in enumerate is connected, what we so if index in visited continue, and now we just do visited.add index. So now for let me just move the camera to the left side. So for node to visit in nodes to visit, wait. If node to visit, oh, now we just say stack dot append nodes to visit. And that's it. However, we forgot something. So visited.add and provinces counter plus equals 1. So now we do this, and now we can just go while stack, and we pretty much repeat the same thing. So stack node equals stack dot pop. Let's pop the first one. It's a bit irrelevant, but yeah. If stack node in visited continue, else visited dot add stack node. I'm like repeating code from up here. There might be a way to write this code and in a way that doesn't repeat, but for the sake of the explanation, let's just keep it this way. So I add this, and now what I can say is, what I can do is nodes to visit stack, I'll just call it stack nodes to visit equals is connected of the stack node. Well, do I want to append this, or should I? No, I should append the index. I was doing it wrong. For a node to visit, wait, index to visit enumerate if node to visit, then stack.append index to visit. Stack nodes to visit, and then if, so for stack node to visit in stack nodes to visit, same thing. Index, and then Same thing that I did here. If node to visit, but I just need to go stack. Okay, and then at the end I just return a province counter, provinces counter. Let's just run this. Okay, cannot unpack something that is unpackable because I did not set it as enumerate, which I wanted. Provinces counter should be 1. Okay, let me just add a new node, just like I did in the example, that is all alone, a very lonely node. Provinces counter is 2. Okay, I'm feeling confident. Submit. And it works. So both of them are green. I'm happy. Hope you guys are happy. See you later.